This meeting is being recorded.
All right, so we've looked at a couple problems that dealt with alkene nomenclature. So we're going to continue with that, but now we're going to look at what's called a bicyclic compound. If you remember when we first learned about bicyclic nomenclature back in chapter 4, we're going to apply those same rules to start here, except we just have to designate this pi bond. So that's the only new thing that we're going to do with this type of nomenclature problem. So as always, we identify our parent. When we have a bicyclic, we count the total number of carbons involved in both rings. So this numbering will not stand, but I'll start here. So there's one carbon in this bridge. Then we have 2, 3, 4, 5, 6, 7. So we have a hept, right? H-E-P-T, root for our parent. But we have to designate it as a heptene. And the reason I'm leaving this space here is because we have to give the locant for our double bond. And after we figure out the longest bridges and things of that nature, and how to get the lowest numbering system for our substituents, we're going to renumber this structure a little differently. So speaking of that, let's take a look here. So I always start my numbering at a bridge head. So that would be here or here where the two bridges connect. So I have to travel down the longest bridge first. So I have two-membered bridges. So I am going to venture down this direction. So I'll start with 1, 2, 3, 4, because this is a 2-carbon bridge, and then I'll continue this way, 5, 6 to my other 2-carbon bridge, and then I'll end with 7 up top here. So my locant for my double bond, for my pi bond, would be a 2. So far I have hept2-ene, and what's left is to name the other two substituents and add the term here, bicyclo, in front. So we have C-Y-C-L-O, bicyclo, and we discussed the bridges are 2.2.1. So I'm going to try to squeeze the whole name in here, and then we'll rewrite it with these substituents. So we have this bicyclo 2.2.1 hept2-ene as my parent, and let's add those substituents. So we have dimethyl on carbons 2 and 3. So let's write it all out here. We have a 2,3 dimethyl. And then we just cram this all together by cyclo, and then we list the bridge heads starting with the longest bridge, so 2.2.1, hept for our parent, 2 for the locant of the double bond, and then we end with the ending ene because it is an alkene.